In this lesson, I'll show you how to solve exponential growth and decay problems with differential equations. This is question number 2. The question reads, suppose that a rumour spreads according to the equation dp over dt is equal to 1.1 times p. If 3 people know the rumour initially, how many people will know the rumour as a function of time? Now, given our equation is written in terms of p and t, we can write our function as p of t is equal to something, and that's our job to find. We're also told that 3 people know the rumour initially. So at time 0, we have 3 people knowing the rumour. So how do I find p of t? What I have to do is treat this as if it were a differential equation. Let's go ahead and see if we can separate dp and dt. We have dp over dt is equal to 1.1 times p. What I'll try to do is isolate the dp terms on one side and the dt terms on the other side. And we can do that quite easily. In fact, if I multiply both sides by dt and then subsequently divide both sides by 1.1p, I'll end up with the following equation. dp over 1.1p is equal to dt. Now I can integrate both sides with respect to the letter that they represent. So I'll integrate this side and I'll integrate this side. I'm going to start with dt. I have the integral of dt as t plus c. This plus c part represents the constant. And the reason why I put it on the side of the t is because this function is with respect to t, time. Now we need to find the integral of this function. I'll pull out 1 over 1.1, and I end up with 1 over 1.1 times the integral of dp over p. The integral of 1 over p is ln p. So I have 1 over 1.1 ln absolute of p is equal to t plus c. Now that I've gotten this far, what I'll do next is multiply both sides by 1.1. That will clear the denominator on the left side. Ln absolute of p is equal to 1.1 t plus c. Now you're probably wondering, if I'm multiplying both sides by 1.1, why don't I put a 1.1 in front of the c as well? I mean, aren't I multiplying this whole expression by 1.1? Well, it turns out that you don't need to put a coefficient in front of the c, because had we done this step earlier, let's say we had placed this 1.1 here and then integrated, we would have ended up with 1.1 times t plus an arbitrary constant c anyway. So that doesn't matter in this particular case. Next, I want to solve for p because, remember, they want a function for p with respect to t. To get p isolated, I'll raise both sides to the base of e. This goes away, giving me p is equal to e to the power of 1.1 t plus c. Now, because originally that p had the absolutes around it, and now that it doesn't, what we have to do is write down plus minus on the right side, just to indicate that we don't have these absolutes anymore. Then I'll use the laws of exponents to rewrite it like this, as plus minus e to the power of 1.1 t e to the power of c, and I'll set this part of the equation as another letter. Let's call it m. m times e to the power of 1.1 t is equal to p. Now remember, originally we knew that at time 0 there were 3 rumours circulating. So to find out what m is equal to, I'll change this into a 3. I'll change this into a 0. We end up with 3 is equal to m times e to the power of 1.1 times 0, which is e to the power of 0. Anything to the power of 0 is equal to 1. Therefore, m is equal to 1, and our final equation is p is equal to 3 times e to the power of 1.1 t. And there you have it. That is how to solve exponential growth and decay with differential equations.